Howdy friends, welcome to All About Relay channel. In today's video, we will see how to use RTMS home screen and fall calculator feature to test the impedance relays. Uh, this tool can be used in multiple purpose. One of the use we can test the impedance relays or line production relays. Any relay, it may be ABB Ariel 670, Siemens 7SA522, or a new Siemens Dixie 5 series relays, or a GE relay, or any relay, you name it. We can able to test simple, like to make sure the relay characteristics like impedance characteristics looks intact or not, that we can able to test it. Let's continue to the video. Let's say example of ABB Oriel 670 relay or SEL 411L relay in this video. Test impedance relays manually, we can use the fault calculator. This is the continuous series of video we are making on the RTMS home screen testing using the fault calculator. Click on this fault calculator icon. We get the impedance mode option here. So selecting impedance mode, we have options for selecting the fault types. All the fault types available here: ABC fault, AB, BCA, CA, A, B, C. So individual fault types. We know, like when we select three-phase fault type, it's a pretty straightforward. Assume like I want to test the impedance at 3 ohms with the fault value of angle is like 75 degree. Then fault current, I want to inject a 2 amps constant current. The pre-fault, I want to set 1 amps, and healthy voltage is 63.5. So when I pick the constant current mode, so when the injection is happening with the 2 amps for the fault current, based on the 2 amps, the fault voltage is calculated according to the fault impedance setting. So let's go back to the test screen and see how the values are set. You see here, we set impedance 3 ohms, the fault current is constant 2 amps. So based on the impedance value under the fault current set, the fault voltage is calculated. And also you can notice here the impedance values 3 ohms at 285 degree or whatever the fault angle it calculates. Then we have the fault voltage and fault current which is going to be injected. So by press play button here, so the test set will inject the pre-fault value and inject the fault values. If the relay operates, we click simulate, and once the test is done, we can add this to the test results. So I can say like in this say example, this is the zone 1 ABC fault test. Since it's a zone 1 ABC fault test, we can enter our expected value. Normally zone 1 is like 0 millisecond, so we can enter some value 35 millisecond. So if I enter min value 0 and max is equal to 50 millisecond, if the operating value or measured value within this fall within the tolerance, then we will see the pass values. Let's go back to the home screen and do some other impedance fault type testing. Here, going to the fault calculator and select impedance mode. This time I want to do single phase fault type. We know single phase fault type comes with the compensation factor. Even this tool provide the compensation factor for various relay types. So we know already it's a constant voltage or constant current or constant source method or supply method. In this case, I still keep constant current. Since I selected the single phase fault type, I can have a ground compensation, right? So the phenomena in the ground compensation, it's very important to apply in case of impedance relays testing, right? So it's varies depends on the fault impedance, ground transmission line to ground foot impedances. It comes with a various factor calculation on the relay setting. So we should take care of applying that compensation factor. Otherwise, we test a relay or characteristics wrongly. So we provide multiple options: either no compensation, the KN factor, or Z0 by Z1, RE by RL or XE by XL. So it's like a KN factor is a very common. And the Z0, Z1, these two are very common. RE by RL or XE by XL, it's mainly used in Siemens impedance relays. So if I select my ground compensation, you can see the magnitude and phase angle selection. In this case, I set zero point 0.9 and also like minus 10 degree. Then this point, this is the vector value, right? So zero point 0.9 at minus 10 degree, it is applied to the actual fault impedance. We are looking for 3 ohms. So the compensated value, if I leave this screen, the compensated value will be applied. Since it's only A phase fault type, you can see A phase fault current is applied. We selected constant current, then the fault angle, and also fault voltage. It does calculated automatically. And also after the compensation, this is the real impedance. So we know we set the fault impedance value 3 ohms, but after applying the compensation, it's a reflected impedance, or we sometimes we call loop impedance, is 5.68 ohms at minus 70 degree or 289 degree. This is what it's been calculated. Now if I run the test, we can see the fault is applied pre-fault, then simulate the fault and add to the test results. And we know like this is a zone 1 AN fault timing test. The same here, we can define our expected value as a 35 millisecond and min max is 50 millisecond. If the relay operates within the time, so we know like a relay is paused. If it is like more than the min max value defined, the relays, the test report shows failed. So to show pause, like say example, I said this is a 2 second, you can see it said pause. So I go back to the home screen. It's a pretty straightforward, simple tool for quick testing the impedance relays. Say example, when you connected very first time, you want to do automated testing. You want to make sure your settings or the relay is operating on each zone or not. You want to verify it. So you simply plug in your expected value. Say your zone 1 is like 3.5 ohms. So you give something less than 3.5 ohms here, 3 ohms example for zone 1. If you want to test a point in zone 2, assume your zone 2 is 5 ohms, you may set like less than 5 ohms, like 4.8 ohms, and test it manually. This is the very powerful tool. It's help the user or operator to run the manual testing of complex impedance relays. This is not easy, right? We are doing nowadays with automated test tools, but this is pretty easy, and it's like a old way to you can visualize how the relay is operating by mathematical calculation. So in the next video, I will go continue talking about maybe symmetrical mode and power sync mode. I will cover in the next videos. On In this video, one more thing related to uh, impedance testing, there is one more tool is available in the fault calculator. It's a called fault location mode. This is similar to impedance mode, but you want to define your what is your fault impedance, your 100% transmission line impedance. This is the percentage of line is 3 ohms. So the 100 percentage you can set whatever. So you want to apply for like 80 percentage of your line impedance. So then my percentage impedance is 100 percentage is 5 ohms. That means like uh, the fault will be applied 80 percentage of your 5 ohms. That's what it means. In the fault location testing, it's very important we apply the fault value, maybe 80 percentage of fault we inject for the product airline, or 60 percentage, whatever it is, the product airline we are applying, and we apply the fault voltage and fault current. Relay operates, not only relay operates on the particular impedance, it also displays the fault distance. It's a very very important feature every impedance modern impedance relays has. So if I, in this case, my 100 percentage of line is 5 ohms, I want to apply fault 80 percentage. So based on that selection, it's a similar, we put the values, and when we press the play, then fault values are applied pre-fault and fault. If the relay operates, then relay will we can compare what is our fault impedance value and fault percentage we set and what is the measured. So it's easy to compare. It's quick manual testing to measure the fault location. So in the next video, I would like to discuss two, symmetrical mode and power swing mode. It's very quick. We can test that one. Power swing also another powerful tool. The quick testing we will see in the next video. Thanks everyone.